Hello and welcome back to our data structures and algorithm series. In this video, we are going to look into how to create a node, a linked list node. Remember that a linked list node has the data part, which stores the data, and also the memory address part. And this particular node is actually stored at a particular memory address in memory. For example, 1008. And I've just written this memory address in decimal number system, which is what we use for our day-to-day numbers. But really, cells in memory are actually numbered using hexadecimal. So initially, when you create a node, the link part is going to contain a null, and as we said, the null simply means the absence of something in that particular part of memory. So it's not going to point to anything because we do not have any other node anyway. This is the only node. So that is it about that. But as you create the node, normally you'll pass to it a value that is going to be stored on the data part. So let's jump right in on Visual Studio Code and do exactly that. So on the terminal, we are going to use the command code to create our file. So you can use the command code to create your file by writing code, then the name of the file. You can just call this singly linked list. Let me just make it a bit long, .py operations. So this is supposed to be operations.py, like that. So if I create that, then I have a singly linked list operations.py. So in Python, we create linked list, the node, by using a class. So normally you will do class. It's supposed to be, remember Python is case sensitive, so it's supposed to be lowercase. Then the name of the class. And for the node, we simply call it node, like that. Then a full colon, then inside it now you can do the methods for that particular class. One convention for Python, naming convention, is that the class name should always follow the camel case, and even the first word should have a capital letter. So that's why N there is in caps. So we're going to create our first method, and this method is the initialization method, also known as the init method. In other programming languages like C, we call it the constructor. So this method is not called, it's automatically executed when you create an object of this particular class. Now, in Python, every method in a class that will interact directly with the objects that are created from that particular class should receive the self attribute. So self is used to point to the particular object that has called that particular class at that particular time. So the first parameter that any method in a class that interacts with objects of the class should have is the self. Then after that, we also want this method to receive data. So that is just a variable called data. Okay, then inside here we can say self.data. So now we are creating a variable called data, and we want it to receive that data that we passed to this particular function. And we will also do self dot, then we create another variable called next. Now this is the next, this is the memory, the variable that is going to store the memory address of the next node. For now, we just want it to store none. Now, none is same as null in other programming languages. So in Python, none signifies the absence of a value at that particular memory address. So we just want it to store none. Then once we create another node, we can point it to the next node so that it can store the memory address. of that particular node. Okay, so that is it about this class. So we can actually now get out of this class by just moving out of the indentation, going back to the very beginning so that we are outside the class. It's a good habit to comment your code. So I'll just say here that we are creating the node class. Then inside here, I can say that this is the initialization function. We can say it will receive the data of the nodes. Okay, good. So here now we want to create the node by creating an object of the class node. Okay, so how to do that? We just do a name. For example, I want to call our first node A. Then we can call the name of the class like that. Then we do round brackets and pass it the value A, because that is what we want it to store. So remember here, I have just created an object of the class, which I'm calling node A. If you want to access the values of this particular object, then this is how you do it. Access the data of the created node. So I can just do, for example, print like that, then the name of the object, then dot. Look, if I do dot, it actually lists the possible what we call the data members of the class. So we have data and we have next. So I can just click on data, because that is what I want to print, and it should actually print A. So I'll just save my work. Then I'll go here and just run. So Python. Okay, good. So you see, if we run our code now, we actually get A. So that is what has been stored for that particular object. So let me also print next and see what we are going to get. Okay, so node A, but instead of data, we just print next. So what are we going to get? I'll save. Then I'll do Control Alt N to run. So you see, now we have A and we have none. So next has none. It's not pointing to anything because we've not assigned it to anything. So it's just receiving the default value, which is none. So I hope you're starting to get the gist of how this is working. We've just created a class, and we've created a constructor, which when we create an object, it's going to receive some data, which is what we are passing here. It's going to be saved on this variable data, and it's going to be assigned. So we can be able to print node A.data and also node A.next. Okay, let's create another object. Let's say node B. So in a similar manner, we are going to do that. Then, for example, pass it B. Of course, we can pass it any other value. So we're just passing B. Then we can also create node C. Node C like that. Node. Let me just be consistent with that so that I'm using just the single quotes. Okay, good. So what I want to show you now is the memory address. the memory address of the object. Now, if I do print node A, if I do print node A, I should be able to get the memory address of this particular object in memory. So let me just comment out this and this, then I'll save my work and run it. Good. So here you can see that this is an object from class node, and you can see that this object has been stored at this memory address location. So this memory address location here is actually in hexadecimal. So similarly, we can be able to print for the memory address for B and also for node C. So I just want you to see before we go on and link these nodes together to form a linked list. Okay, so if I run Control-Alt-N, you can actually see that node A is on this address, node B is on this address, and node C is on this address. Actually, they're the same. They're starting to differ from where? From here. You can see they're actually on different memory addresses, random. Remember, we said that for linked lists, each node is allocated different memory addresses, so not contiguous like arrays. So you can actually see that A has been stored at FD0, this one EE0, this one E80. So they are random. Okay, so I was just showing you that so that you can appreciate that indeed when you assign a variable to a node, then you are actually referencing to the memory address of that particular node. So let's see how that works out so that I don't sound so confusing. Let me show you how that works out. So I'll just comment this out. And then now, so far, the next variable for all these objects are actually none. So now we want to link the nodes together. So if we wanted to link the nodes together, how would we do it? So you guessed it right. So node A, then dot next, like that. So it's next variable. Then you want to link it to node B, like that. So if you do that, then you're simply saying that you want this variable for this object to store the memory address of node B. And we can actually confirm that by printing this. So let me just print that, and also print node A dot next. So it should give us the same memory address. So node A dot next and this one. So I'll just save my work and then run it. And we can see, look here. So you can see that now A dot next is actually storing the memory address of node B. So I hope you've been able to understand that. Okay, so really that is how we link up. That is how we link up nodes so that they can reference to the next node. So here, if we wanted now to form the linked list, we will have this dot that is equals to node, you guessed it right, node C, like that. And now we have a linked list. We have a linked list that is moving from node A to node B, then to node C. So node C dot next is just going to be none because it's our last node. So it's not going to point to any other node there. Now, something interesting, let me show you. Actually, what do you think would be the output of this code? Next dot data. So if I do node A dot next dot data, so remember node A dot next is actually node B. So if I do node A dot next dot data, is actually same as doing node B dot data. So this should print out a B, which is the value that has been stored at node B. So if I save this, then I run the code, you can actually see here, that the output of this particular code is B, is B. And actually, you can also do this. And it's important that you understand this because when we start implementing the functions for the operations, then we are going to be using node.next or even node.next.next. So like right now, if I do next.next, what do you think will be the value of node A dot next? Okay, so if you guessed that it's going to be actually the memory address of node C, then you're right. So I'm just printing here node A dot next, and I'm also printing node C so that you can see if the memory address is going to be the same. So I'll save my code, then run. Let me just clear, then run. Good. So you can actually see that node A.next is actually storing node B.next, which is pointing to the memory address of node C. So it's actually the same. So you can see that the memory address is actually the same. So it's actually possible to do a node.next or node.next.next. Even it can go, if we had another node D, for example, we can do next.next.next, and it's just going to be able to move on and on that particular list. So generally, okay, I think that is what I really wanted to show you in this video, just to make you appreciate how we create a node and how we pass data when we are creating a node, and also how we can access either the data part of a node or the next part of a node, and the fact that actually each node is actually a memory address, and therefore if we do A.next, then we assign it to B, then A.next is going to now point to node B. And if we do A.next.data, it's actually going to print out the value of B. So this is, I felt this was a bit necessary so that you can appreciate now the nitty-gritties when you go on to implementing the linked list class. Now here, we've just created this linked list manually, but in our next video, we are going to now implement a linked list class, which is going to, you remember the head? So it's going to implement the head variable that is going to point to our first node. Then we're going to also implement the function to insert, the function to create a node, and also the function to insert a new node to a linked list. So I hope you've enjoyed. Let me know if you have any questions on the comments below. Otherwise, thank you so much for sticking to the end. See you in the next video where we are going to implement the linked list class and at least the insertion operation. So thank you and bye for now.